Lesson 4, how many pairs of shoes do you own? So in asking this question, what we're trying to do is gather some data that we can display in a stem leaf plot. So number one, we really didn't record the data for the class there. We gathered it through STApplet. That would be number 3. This is quantitative data because we're just talking about numbers of shoes. Let me show you what the that data looked like. So let's see, let's insert picture. Let's do it off to the side here. And it would be this one. Oops. There we go. Where did my picture go? Okay. So here's one class's data for that. And so we've got a bunch of people in single digits. That's the 0 line. Our maximum was 50. That's the line at the bottom. And also joined by a 40. Notice we have a key provided by STApplet right here. So that tells us how to read the scale on this. And so this is called the stems over here on this side. And everything over here on this side, these are called the leaves. And if we turn our head to the right, we can see that the shape of this distribution is skewed to the right, or skewed toward higher numbers. What percent of the students in the class have 10 or more pairs of shoes? There were 16 numbers that are here represented in the table. And the number that are 10 or more is, there's actually just 4 of them. Here's the 4. So 4 out of 16, 25% were more than 10 shoes. And are there any outliers? Actually, yes. When we went to a box plot, we found out that these two are outliers, definitely. And they're outliers by definition. They are far from the rest of the data. And try splitting the stems in 2. So what that means is take every line of the table and split it into a low side and a high side. So in other words, this would be one row, and then we'd make another 0, and then these numbers would go in there. Now, why would you want to split a stem? Well, splitting stems is like zooming in, and also it helps us to look at the question of, well, if we have a lot of numbers on one line, are they clustered near the bottom of that interval or the top of the interval, or are they evenly distributed? Here they're evenly distributed. There's 1, 2, 3, 4, 5 numbers on the lower single digits, and 1, 2, 3, 4, 5, 6, 7. So 5 versus 7. 7 that are on the high single digits. That's fairly comparable to each other. Now, when we look in our notes for this, the stem are the first numbers, the leaves are the last numbers. You can represent decimals. We did watch the Against All Odds videos where they showed that. We don't skip stems. Did you notice that in our stem leaf plot? There were no 30s, but still we wrote a 3 because that helps to see the gap. Seeing the gap is also an important feature. When we split the stems, we have an equal number of possible leaves digits. So in other words, when we split the single digits, we went 0 through 4 and 5 through 9. That's an equal number of numbers. See, 0, 1, 2, 3, 4, that's 5 numbers. And 5, 6, 7, 8, 9, that's also 5 numbers. And the reason you might want to do it is it might show you the shape more clearly. Now, back-to-back stem leaf plots is not in this lesson, but the reason you'd have to be careful of skew in back-to-back stem leaf plots is you have common stems in the middle, and then you have numbers off on either side. Now, for the one that's over here on the right side, if you turn your head to the right and you look at it, it will show you the shape, either symmetric or skewed. But if you do the same thing on the one on this side, even if you turn your head to the left, it looks like it's skewed left, but it's actually not. It could also be skewed right. So a better thing to think about when it comes to skew is, are we skewed to the lower numbers or are we skewed to the higher numbers? And that led us into our application. So we're going to go ahead and stop the video here. See you in lesson 5.